Hey everyone, Michael from Bart Musical Circuits. This is the divided sequencer schematic. I'm going to go through this. And this, on paper, looks like a much more complicated module than it really is. It's a lot of green lines that cross over each other in this, but it's not really, there's really very little going on. So the heart of this is the CD4051 analog switch. So it's a switch that has one common point that goes to 8 other points to it. So the X we're using as our output, that's our common. And then these eight pins over here are input pins. And so our output, that is going to a buffer and going onto the jack through the 1K. And our input, that is the wipers of the 8 pots that we have up here. These are in yellow because they're on the panel board. We have these numbered wire pads. That's the pin that connects between the panel board and the top board. The top board has all the chips on it. And these are all just simple voltage dividers. This toggle selects whether it's plus 5 volts or 2.7 volts. And then this is a 0.01 UF cap to filter that divided down voltage just a little bit in case there's any switching noise. But yeah, those pots connect to the inputs of the 4051. And all of these 4051s have those inputs set to the exact same ones. So they're all seeing the same position of the same pots. And our outputs are just switching which pot that 4051 is looking at. And how it knows which one to look at is it looks at the 3 pins ABC down here. These are going to form a binary number between 0 and 7. So a 3-bit number. And the trick to this is that the 3 bits that we're using are 3 different bits off of the same number to get a divided down version. The 4024, this is a binary counter. Our first 3 bits, those are the 3 bits that we're using to form a 3-bit number here. But the second 3 bits, that's what we're using over on this third one. And then the same thing, it keeps on going, that you'll see that these connect over here but one down, and that connects over here but one down. And basically, if you're familiar with the pattern of binary numbers increasing, it is this thing of it's moving from least significant to most significant. The most significant bits change at half the rate of the less significant bit before it. And so by doing it this way, we're automatically just dividing down the speed at which these different outputs are going to change. All that's left to really look at here is our input circuitry, which is really simple. This is our clock input jack. It's tied down with 100K there, and this goes into an inverting comparator. Our clock has an inverting input that it wants a negative pulse to tell it when a clock hits on the 4024 itself. So all we do is we have this diode here and then a pull down resistor coming off of this. The thresholds for both comparators are set by this voltage divider network here. And then the reset works similarly, except it also has this 0.01 UF. This just forms a little filter with the tie down resistor. So we're just getting the pulse. And we're doing that so the reset doesn't last so long that it blocks out a clock hit. And that is pretty much how this works. Oh yeah, I guess and then the other thing to look at would be the power. We have a 5-volt voltage regulator. All of these CMOS chips are going between ground and plus 12 volts. The plus 5 volt is just for the pots. And then there are caps on them for filtering. The one op amp is getting powered by plus and minus 12 volts. And then we have some more filtering of the power supply with this 10 and 10 low pass filter here. Yeah, and that's basically all this is. Like I said, it was a pretty simple module. So yeah, thanks for watching.